So if we substitute our integral here, our limit, that from r, it means instead of writing y, we should substitute is equal to r. If we substitute now and simplify our equation that from r, it means to substitute r alafu tutaweka minus alafu mabano tena, and after there we should obtain that by simplifying the equation number 4.35. Now we should get the total moment of inertia I of the solid sphere about an axis through its center must be equals to 2/5 mr square. So this should be the formula of obtaining the moment of inertia for a solid sphere. Kwa ukiambiwa kudemonstrate the moment of inertia for a solid sphere, their formula should be equals to 2 divided by 5 times r square, where m represents the mass of the solid sphere, while the r represents the radius or the distance of the solid sphere from the axis of rotation. So after this one, now let us go and see the examples related with what we tried to read here. Twende tukaangalie mfano unaohusiana na hiki ambacho tumejaribu kukisoma hapa. So my dear student, we have our example number 4.5 as we observe. And our example say that the mass of a solid sphere increases by 1%. What will be the percentage increases in the moment of inertia about its axis of symmetry? Let us repeat it to read our question again. Our question is say that the moment of the mass of a solid sphere. Now we have the solid sphere, and that is solid sphere containing the mass which increased by 1%. Now, what will be the percentage increases in the moment of inertia? If the sphere having the mass which is increased by 1%. Now, how much percent does the moment of inertia should be increased about its axis of the symmetry? Now we assume we have the solid sphere trying to rotate about an axis through its center, and it is mass increased by 1%. Now after this one, after increasing it by 1%, how percentage does the moment of inertia should be increased when the mass is increased by 1? This is what we are supposed to go and find into our equation here. So my lovely student here, what we are supposed to do? The thing that we are going to do here is to differentiate at the moment of inertia I of the solid sphere about the axis of the symmetry. Now consider our equation in number 4.36. Now we are supposed to go and apply differentiation. Now we are going to differentiate the moment of inertia. And after differentiating the moment of inertia here, we are supposed to go, we are going to differentiate it with respect to mass m. After differentiating, by consider this equation here, the equation number 36 for our first topic, we should obtain that di, our equation said that di must be equals to 2 divided by 5 times mr square. But this times r square dm. But this di represented the small change of the moment of inertia, while this dm represented the small change of the masses. And we have been told that we are supposed to differentiate our equation here with respect to we are supposed to differentiate with respect to their masses. Now after differentiating, now we should obtain the fractional change in I is the ratio of di that of I, which it gives to this one. So the fractional change in I, the fractional change in I must be equals to the ratio of the di, then we divide it by I. This should be like this one. So after this one, my dear student, after integrating, it means that after integrating this one, we should obtain the fraction of the moment of inertia, which is equal to di. Then we divide it by I. That should be the fraction of the I. It means the moment of inertia. Now, my lovely student, after this one, as I told you that after differentiating this one with respect to m, now we have been obtained after differentiating, or after differentiating, we have obtained the fraction of at the moment of inertia, which is equal to di divided by I, and also the fraction of the mass must be equals to dm divided by m. This is what we tried to obtain here. After this one, but the percentage increase in at the moment of inertia I about the axis of the symmetry must be obtained as it following here. So baada ya kuandika sasa in terms of the fraction, now we are going to look for the percentage increase of the moment of inertia when the mass tried to increase by 1% for a solid sphere. That is what we are going to try to observe here. So as we see here, what we are supposed to do in order to substitute our given values into our formula here, we are supposed to introduce the percentage throughout. Now we should introduce the percentage here. It means either you can multiply by 100% throughout. It means at the left one and also at the right one. If we multiply, we should obtain that di divided by I, which represent the percentage. It means the fraction, the percentage of the moment of inertia equals to the percentage of the masses of that solid sphere. Now it can be like this one, my dear student. As I know that after introducing the percentage, we know that the mass have increased by 1%. Now we are supposed to go and substitute the value of the masses. We should substitute the increase of masses for a solid sphere, which is equal to 1% as we observe here. Now after this one, we should conclude by saying that therefore, since the percentage increase in the mass of the sphere is equal to 1, it follows that the percentage change in the moment of inertia is also equals to 1. Why we say that this percentage increasing? As we know that the moment of inertia is directly proportional to the mass. If it is directly proportional to the mass, when the mass of a solid sphere increases, and also it facilitates or it can cause the moment of inertia to increase also again. Kwa kama ile mass of fraction, ile percentage of the solid sphere iliongezeka kwa 1%, basi kumbe na ile moment of inertia itaweza kuongezeka kwa 1%, kwa sababu tumesema kwamba hivi vitu vinakuwa vinawiana, kwamba kama moment of inertia ataongezeka, basi na yule masi ataweza kuongezeka. So after this one, my dear student, now we should have a task here, and our task should say that you have to try to demonstrate the moment of inertia for a solid sphere. And the second task is that when the solid mass of the solid sphere should increase by 20%. Now, how much the moment of inertia should the fraction the percentage of the moment of inertia should be increased? That is your task, my dear students. So by saying that this should be the end of our session here. Now, I would like to welcome you again for another session. I wish you all the best. Have a nice moment.